Okay, we're going to take a look at what information we should consider gathering from either the ATA191 or 192 if you need to troubleshoot something on either of those devices. So first I'm going to start off by comparing the physical layout of the 191 compared to the 192. You notice the 191 is fairly basic. It has a plain old telephone line, so it has line 1, line 2. It has then a network connection where you plug it into your LAN network. It gets DHCP. The 192 is similar except for it has an additional port. I'm going to click on this, and you notice it says Ethernet. So the 192 acts as a mini router. So you still plug in the network port to your network, and the 192 will get a DHCP address. This is assuming, this is using kind of the default settings for most of the settings. You haven't configured static. It would get DHCP address on this port, but to manage the actual ATA192, you would plug in your PC into the Ethernet port. This again assuming that it's left in router mode. There is a mode that you can actually configure on the ATA192 that's bridge mode, and you do not have to plug in this PC, but I've left my unit I'm going to show here kind of in a default setting in a router mode. So I did plug my PC into the Ethernet port, and what happens is when I plug my PC into the Ethernet port, and I'll bring up a DOS prompt, you'll notice that the PC gets an IP address here of 192.168.15.100. So the ATA192 is acting as a DHCP server for the PC. And then the actual IP address of the ATA192 is going to be 192.168.15.1. So again, this is assuming that the ATA192 is running in router mode, which is the default setting for it. I plug my PC into the Ethernet port, and it's going to get that IP address from the ATA192, which if we go back here is the 192.168.15.100, and then to web into the ATA192, we're just going to simply type in 192.168.15.1 in our web browser. And so once we log in, we want to focus in on, as a starting point, on the administration tab, and then we want to go under log and debug log module. One thing I would like to point out is I am logged in as admin. Be aware, if this is registered to certain platforms, you may not have admin access to log in. If that is the case, then you want to work with the respective technical support and or service provider support team to understand what type of method they would like you to use to collect this information. So here we're going to say we're troubleshooting, but we right now don't know yet what is going on. So a starting point is you can go and enable all of these if you're not really sure on specifically what item you're focused on from a troubleshooting standpoint as a starting point. And then as you're going through the troubleshooting, and it's not media, it's not NTP, it's not CDP, LDP, etc., etc. You can take some of those elements off. But as a starting point, if you're not sure, then you can collect as much information as needed, and then later if needed you can trim some of that off. So once you select, you're going to hit submit. I've already done it here. The next one we want to take a look at is debug log setting. So in a situation where the issue that you're troubleshooting is intermittent, aka random, where it may take hours, days, or weeks for the issue to be reproduced, the logging on the devices is finite. So you may want to point this to an external syslog server for it to be logged in an effort that the information is not overwritten once the issue occurs. And let's say it's the weekend or you're not available in office to be able to download the information before it's overwritten. If the unit is busy, the information can get overwritten fairly quickly. So in this case, what I'm doing is I'm pointing this to a PC, which is the PC we're on right now. ATA192.168.15.100, and then I'm simply running an application called TFTP-D64. One of the features on this application is going to be the syslog function. So on the syslog tab, what I did is I enabled the option forward message to pipe TFTP-D32 syslog. This allows the operating system to forward the syslog information to the application. And then the next thing I did is I'm telling it to save the syslog messages to a syslog text file in effort that this can run for days, weeks as needed. If I go to my folder, what we're going to see here is going to be the actual log, the syslog. So I'm just calling it ATA192 syslog. If we double click this, you'll notice the different messages are being logged here. So this allows this to run hours, days, weeks. So when that issue occurs, if it's an intermittent random issue that might be sparse in nature, at least you have an opportunity to be able to capture it. Okay, so I'm going to go ahead and just cancel because I have everything set up here as needed. So we're going to just go ahead and minimize this. The next thing we want to take a look at is the debug log viewer. In this case, what it's doing, it's outputting this information on the screen. So I'm just going to scroll up. But this is one of the items we want to actually download. So we're going to go download log. Okay, we're going to keep this. Next one's going to be event log settings. And same similar situation as we looked at a few moments ago. I also have this pointing to my syslog server 192.168.15.100, and it's basically sending this directly to it. Again, you may not need to do this, but if it's a situation where the issue you're troubleshooting may be sparse and or very random in nature, where it may take hours, days, and weeks for it to pop up again, this should be something to consider in effort to get the best chances to collect the needed information, aka evidence of what might be going on. And then the next one we want to look at is going to be the PRT viewer. Okay, and then we want to go here to where it says generate PRT. So one of the things to keep in mind is you want to do this as soon as the issue occurs to generate PRT. Obviously, you would have the logging going to the syslog server as we looked at a few moments ago. But in conjunction with that, we want to go ahead. This is going to create a bundle of different type of log information that it's going to capture. So if the issue occurs, either yourself or somebody else, you want to educate that, as soon as the issue is noticed, if someone can please go ahead and generate the PRT. And this is going to take a few moments for it to go and collect all the different log information and then consolidate into one file. So we'll give it a few moments here for it to do the capturing and then the compressing of the file. So this would be the tar.gz file. So then we can download that also. And then the PCM, this is something that depending on what you're troubleshooting, and this is where you may want to first get feedback from the technical support, the service provider you're working with. Is the PCM data going to be needed or not? So I did a test call here where I submitted this. This is about 60 seconds. By default, it's 60 seconds of capture time because there's limited space in the unit itself as far as logging. It gives you a range of 20 to 300 seconds. I left it on 60 seconds. I did a test call, and then it went ahead and generated these PCM and also RTP files that can be used by tech support / sustaining / development team to do diagnostics. So in this case, if you are troubleshooting something that requires PCM type of information and or RTP, you can go ahead and generate this, and then you can go ahead and download this. And you notice it does another tar.gz. And there's some additional items here. So for example, If the tech support / service provider we're working with is calling for the CSS dump, you can also enable that and have that generated, and then you can go ahead and download it. Obviously there's nothing here to download, but if that was an issue, that's where you would want to do that, download. And then the next we're going to look at is going to be the crash dump. And this would be another one that unless you're told to do this item, you may not need to do. So in my case, there is no crash dump. So for both the CSS dump and a crash dump, there's nothing in my unit. My unit actually is working just fine. I'm just using this illustration. So next we're going to go is diagnostics. You can do a ping test here. So for example, if you're having registration issues and you're doing registration to online provider, then obviously you want to do some tests here. Is there a connectivity from the ATA to the online provider? So this obviously would be going out to the DNS Google server on internet. You can also do a trace route. These are again some very fundamental items you'd want to do here to make sure that the basics are covered. Is the unit getting valid and needed information from the DHCP server, valid IP address, subnet mask, default gateway, DNS, NTP information, etc., etc. And I mentioned earlier, you want to make sure that the unit has the latest firmware. So as the recording of the video, 11.2.3 MPP is the latest firmware. The firmware update for these units is very simple. You basically would just download the firmware for the 191/192-MPP from the Cisco site, and then simply would find it on your hard drive using the choose file option here, upload it. It takes a few minutes. The unit's going to be rebooted, and very straightforward as far as the actual upgrading itself. And then also it's smart to do a backup configuration of the unit itself here. So you can do backup configuration right here. And if you notice, okay, let me keep this. And that will be the configuration right here. So the next page we're going to take a look at here is going to be the status page. And this is a page you want to go ahead and take some screenshots. So either you're working with technical support and or the service provider, and let's say you're troubleshooting registration issues or something of that nature. These are some fundamental items you want to take screenshots of. This shows us that we have a model that's going to be MPP, meaning it's designed for a third-party call controller, versus there's another model offered of this same 192, which is Enterprise, that's specifically for Cisco Unified Communication Manager. So two totally different units, different part numbers, different firmware. So that would be the first thing, is identify, do you have the right unit for the application you're using? And then the next thing is the firmware. We want to make sure that the unit is running up-to-date firmware. And then they just kind of show some information, time zone, current time. Obviously, we want to make sure that is correct also. That can cause problems if not correct. And then network information. So on the WAN side, which is plugged into the LAN, the local area network, the ATA192 in my environment is getting a IP address of 192.168.1.36 Class C subnet mask. And then on the LAN side, that's where my PC plugs into the ATA192. ATA192, it's acting as a DHCP server, so it's 192.168.15.1. But then my PC, if we go back to the DOS prompt we looked at earlier, it's getting a .100 in that subnet. So we just want to make sure the fundamentals look good. Network status. Probably want to take a screenshot of this also here. Port statistics. Probably want to take a screenshot of this. Memory, another screenshot. And then this is just my PC, what IP address it's getting from the actual ATA192. The other section is going to be the voice section. So depending on what you're troubleshooting, this might be a section where you may need to do some focus towards. Depending on the SIP server or the online service provider provisioning method, some provisioning methods are automated where there's very little you need to do other than making sure that the unit has a minimum version of firmware and perhaps pointing it to a specific URL, and then also providing the service provider the MAC address of your unit. That may be the minimum that you need for your provisioning. In other cases, there may be some additional steps you need to do for the provisioning if that's what you're troubleshooting. So in my case, I have a very basic illustration. I'm using it with a local SIP server. It's an open source SIP server. I'll show you kind of the settings I've used. But if you're troubleshooting with technical support and or service provider, this is another area you want to capture some information. So this would be general product information, the model 192-MPP, the firmware version, again, critical to be on the latest version of firmware, because having outdated firmware is a problem in itself. There's a lot of fixes and other things that get enhanced over time. And then if we scroll down here, there's quite a lot of different statistics. So these are items that you probably want to take a screenshot of, and or you can do a screen scrape, kind of do a copy and paste, whatever works for you. And then since my configuration is fairly simple, I'll kind of show you what settings. So most of the settings you see here I've not touched. They're just the default settings, like all these timers here. RTP parameters, STP parameters, those I've left as is. NAT, it's all standard, nothing special, I've not modified. Likewise, provisioning, because I'm just using a local open source SIP server in my lab, so I'm not doing any special provisioning. However, if you're working with a service provider, most likely they'll have specific information for provisioning. And generally, it tends to be very basic, meaning there's not a lot of information. In some cases, all they need is basically the MAC address of your unit, and then to make sure you have the latest firmware version. And there might be a URL that you may need to add. Go kind of down the list here. Region, this is all stock here. I've not changed anything on my unit. Okay, then we're going to get to line 1. So going back on top here for line 1, I do have mine enabled for line 1, and it is registered to FreePBX here locally. And so line is enabled, yes. And then if I kind of go down the list here, I'll show you what I added, and it's very simple. This is the IP address of the SIP server in my lab, 192.168.1.166. And then I have the extension I'm registering the ATA192 as. It's 2111. And then user ID. So I just kind of use the same pattern to keep things as simple as possible. So those are kind of the basic settings that I have on mine. And then if we go to the syslog server, so let's go to syslog. So what I'm going to do right now is I will go ahead and do a quick test call, just so you can kind of see the syslog collecting information. Testing, 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 testing. Okay, so I just did a quick test call there, and you can see there's some activity being collected there. The other item that we can take a look at here. Okay, so the other item I mentioned briefly, which I did not do in this test call, but as I mentioned from before, is if you are having issues during the actual call itself, you probably want to leverage this PCM viewer option where you can capture PCM and also RTP files. So basically, before you do your test call, you can enable this, capture, submit, and while it's capturing that, you want to go ahead and try to replicate the issue you have, and then once it's finished, you can go ahead and download this. So we can hit download here, and then it's going to go ahead and grab these files and download them in a few moments here. Okay, so it just went ahead and bundled all that information download. One thing critical is you definitely want to document the date and time when the symptom occurred and the description of the symptom, and also if there was a pattern that was noticed before the symptom occurred. You know, was the call being placed on hold, or was the user calling a specific number? Was it incoming call? What is the actual pattern that would go ahead and cause this symptom, whatever the symptom may be? And that generally covers the key items to consider capturing when you're troubleshooting the ATAs. The unit I was focused on really here and I have is the ATA192. And the key difference is the ATA192 acts as a router. So in this case, I have my unit plugged in, my PC plugged into the port here that's listed as Ethernet port. The PC gets that IP address that I mentioned earlier from the ATA192, which is the 192.168.15.100. In your case, even if you have the ATA192, it may not be configured as a router. It may be configured just as a bridge device. So keep in mind what I'm showing you here may not apply 100%, and that's something you'd want to clarify with the provider. So I've kind of left mine default settings as much as possible just to kind of illustrate what it may look like on the ATA192. However, if you're working with a service provider, they may have it enabled for bridged, meaning that you would not plug in your PC into the network port because it would not be needed. You would just plug your PC into the local switch, and then there would only be one network cable from the ATA192 to the network, and you would just need to figure out what IP address the ATA192 has to be able to log into the web interface to get the web interface. The second item might be is the admin credentials. So by default, and I've again left this default settings, it's admin, so username admin, password admin. However, if you're running in production, it definitely is going to have a different password. And so you'd want to find out from the provider, the service provider, how you would access the menus I was showing here. They might have a temporary password they may generate for you, or they themselves may need to access the unit directly working with you, depending on what their policy is. So those are definitely items of consideration. And so hopefully this helps as far as items to consider collecting when troubleshooting an ATA192-MPP or an ATA191-MPP. Thank you for viewing the video.